Let's go to Rahul.
Hello, let me share my screen.
Yeah.
Okay, so hi, my name is Rahul Katari. I am a freshman in Merrill F. West High School in Tracy, California. Today I'm going to be talking about my research project titled Unlocking the Potential of Nanotechnology for Terraforming Mars. Before I start, I'd like to talk a little bit about myself. I'm in the Space and Engineering Academy at my school. I participated in the county level Math Olympiad, placed second, and the county level Science Olympiad and placed third. My hobbies are chess, solving Rubik's Cubes, and playing music. I can play 7 different musical instruments. I think that's enough about me. Let's go into the presentation. So here's the agenda for my presentation. I'm going to start with the introduction, go into the literature review, then the methodology and results, and finally the conclusion. Okay, so what is the purpose of my paper, right? So my paper aims to investigate the possibility of making Mars a habitable planet using.
Sorry, Rahul, we are not able to hear you. It's a bit feeble. You want to increase the volume?
Can you hear me better now?
Marginally, but go ahead.
Okay, so my paper aims to investigate the possibility of making Mars a habitable planet using various nanotechnologies like nanofilters, nanocatalysts, and so on. And it also discusses the sustainability using these methods. So my paper mainly talks about converting carbon dioxide into various usable gases, like mainly oxygen. You might be wondering why I chose carbon dioxide out of all the compounds. Well, carbon dioxide makes up 95% of the Martian atmosphere, so it seems like the logical compound to choose. So the reason I'm conducting this research is because these processes may hold the key to creating a home for mankind in the future. I think this picture over here perfectly shows what I want to achieve. You see this picture on the left where this is Mars and it's a very like a barren wasteland. And on the right side, it's a beautiful, luscious, prosperous planet like Earth. So yeah, here's the literary review. So a similar research has been conducted at NASA. They made a robot called MOXIE, the Mars Oxygen ISRU experiment, which took carbon dioxide and converted it into breathable oxygen. Another experiment that NASA did was using catalytic carbon deposition layer meshes or CCDL meshes. And they use those with ceramic oxygen generators or COG cells. And yeah, those are 2 sources that I used for my research. Here's a little summary, I'd say, of what my research paper is, basically. So I talk about what terraforming is and any drawbacks of terraforming. And I also talk about carbon conversion and carbon capturing. So in order to convert carbon dioxide into anything usable, you need to first capture it. So that's what that part of the research paper talks about. There are 2 weaknesses that I found in my, well, it's not really in the paper, but it's like, if you want to terraform a planet, it's obviously going to take a lot of time and a lot of money to do this. So yeah, those are 2 weaknesses in my argument. This picture over here from Caltech shows simply how the carbon dioxide molecule can be split into just a carbon atom and then 2 oxygen molecules using a gold nanocatalyst. So yeah. methodology and results. So how I collected my data was searching for a variety of research papers and articles in Google, and I cross-checked my references a lot, and I nullified any outdated data. So basically, I did not take any research from before 2017, but less than a good period looking. And my most significant findings were access to the various colonies, like I mentioned. So
I'm sorry, Rahul, we cannot hear you. You're just like significantly breaking up.
Let me turn off my video and see if that helps. Okay, so can you hear me a little better now? Hello. Can you hear me?
Yeah, now it's better. Yeah.
Okay, so here's my methodology and results. So how I collected my data was searching for a variety of research papers and articles. And basically I cross-checked my references a lot and nullified any outdated data. So anything before 2017. And my most significant findings were from NASA, the CCDL mesh and the cogs, and the various nanocatalysts that I found, like gold. And the results of my paper, I found two methods. Both of them started with carbon capturing processes, and then one of them was with nanocatalysts to convert CO2 to oxygen, and another one was the NASA CCDL mesh method with the cog cells. This is a schematic model of the CCDL mesh and the cog cell over here. Basically, it ends with oxygen over here, like after all these chemical reactions. So the conclusion is, my research question was, can we terraform Mars using nanotechnology? The answer is yes, this is very possible in theory. This is very expensive, however, so to make this practically possible, more research would need to be conducted in order to overcome the cost hurdle or the time hurdle. And my contribution to this is my paper. It states the processes by which this feat can be done, and also discusses the sustainability of terraforming Mars. And thank you for listening. I'd like to give a special thanks to Dr. Christina and Professor Virgil for guiding me through this research program. Dr. Christina, I have enjoyed every session that I've had, and I think I've learned more than I could have anywhere else. So I wanted to thank you for that. She also is the one who gave me the idea to use nanocatalysts in this research project. And Professor Virgil, not only did he teach us how to write a research paper well, he also taught us great time management skills, given this increased workload. So I'd like to thank them for that. I'd also like to thank Coach Joe and Gifted Gabber for giving me this opportunity to participate in this research program. Thank you.
Awesome job, Rahul. Dr. Lilova, a question for Rahul?
Yeah, this was one of the most challenging topics, how we can terraform Mars. I think we can, it will just take a while. My question for you is, so when we're talking about CO2 reduction or CO2 decomposition and we want to produce oxygen, are there any other benefits of this reaction? Can we produce something else which would be beneficial for the terraforming?
Yeah, so we talked about this in an earlier meeting. We can convert carbon dioxide into different fuels that we can use, industrial fuels that we can use when if we go to Mars. Because of the abundance of CO2 in the Martian atmosphere, this is very possible to convert into a different fuel.
Thank you.